Hi everyone! In this video, we will analyze a hypothesis test and make conclusions. An economist asserts that the average number of new businesses started in a city each year is no more than 120. You wish to test this claim. Data analysis provides a z-statistic of 1.05. Assume the significance level is alpha equals 0.10. What is the p-value and the conclusion for this hypothesis test? The first thing we need to identify are the null and the alternative hypotheses. The null hypothesis should have either an equal sign, a lesser than or equal, or a greater than or equal sign. The alternative hypothesis needs to have either a lesser than, greater than, or a not equal sign. Let's read through the problem to find our hypotheses. The economist is asserting that the average, we know now that with our hypotheses that we will be using mu because we are dealing with average. Number of new businesses started in a city each year is no more than 120, meaning the very most, the highest amount ever will be 120. And so this means that it will be less than or equal to 120. Because the null hypothesis needs to have the or equal to, this makes this statement the null hypothesis. And the opposite will be our alternative. So we are going to test the claim that it is greater than 120 businesses. Now that we've found our hypotheses, let's write down what else we learned from the problem. We know that we have a z-statistic of 1.05 and an alpha or significance level of 0.10. Let's go ahead and write those down as well. We have a significance level of 0.10 and a z-statistic or a test statistic of 1.05. We were asked to find the p-value and make a conclusion. So to continue making this organized, let's go ahead and list this here, that we're looking for a p-value and a conclusion. Now that we have everything organized, we can go through our tool in Desmos to help us find the p-value, which will then in turn help us make our conclusion. So we're going to use this tool to our right. We know that our alternative hypothesis says that mu is greater than 120. This greater than sign points in the direction of the tail test that we need, so it's pointing to the right. Another way of thinking about it is greater than is larger numbers. So this is a right tail test because the larger numbers go to the right. Using our tool, we're going to click the button at the top to make sure we get a right tail test and move it down 2 to make it go to the right. Then we need to change the significance level, and we were given this is 0.10. So we're going to move it over to 0.1. And the last thing we need to graph is our test statistic, which is 1.05, and this can be a little finicky, so we have to be pretty precise to get it in there at 1.05, which gives us a p-value of 0.1469, which is perfect. We were asked to find the z-value, or the p-value, so we have 0.1469. And now we can compare that to alpha. 0.1469 compared to our alpha or significance level of 0.10 shows that our p-value is larger than alpha, and it puts it outside of the rejection region. So this is a fail to reject. The null hypothesis. We could also have looked at the test statistic and critical value. This also shows that the test statistic stays inside, not beyond our critical value in the fail to reject zone. And this is the rejection region. So we have found our p-value. We've also found the conclusion, And now we're all done.